Okay, so this lesson is about the zeros of a quadratic function. So we're trying to look for different patterns and things we can take note of in terms of how many zeros a quadratic might have without always having to solve them. So first of all, there's an idea here where if you know the vertex and you know the direction that it opens, you should be able to predict the number of zeros. Let's just show this quickly as an example. In this case, I've set the vertex to be 2, 1, right? So D is 2, C is 1, or H and K for this unit, but D and C back to the transformations unit. The vertex is here, the parabola opens up. So the vertex is above the x-axis and the parabola opens up. This means you're not going to have any x-intercepts. Now, of course, if the vertex is above the x-axis but the parabola opens down, you're going to have 2 x-intercepts. Now, the reverse is true. If we stick the vertex underneath the x-axis and have the parabola open down, then we're going to have no x-intercepts. If we have it open up, we are going to have 2 x-intercepts. Can you think for a sec how you would ever get a parabola to have 1 x-intercept? The only way for a parabola to have 1 x-intercept is if the vertex is actually on the x-axis, and then it will have exactly 1 x-intercept. Notice when a is 0, it's not a parabola, right? It's just a flat line, so that doesn't count. But every other one of these, you have a vertex on the x-axis, and therefore you have 1 x-intercept. So here, this little table summarizes this idea. If a is positive and the vertex is above the x-axis, there are no zeros. If a is positive and the vertex is below the x-axis, there are 2 zeros. If it's if it's reversed, there are 2 zeros and no zeros. If the vertex is on the x-axis, there is 1 zero. So here's something I think you should give a try to prove. How many zeros are there if a times k is a negative number? What if a times k is a positive number there? I put greater than 0. What if a times k is a negative number? How many zeros are there then? What if a times k is neither positive nor negative? What if it's 0? How many intercepts are there then? Okay, I want you to give that a try. I'm just going to quickly save this as a more advanced Word file so we can hopefully get the equation editor, but it does not look like we can. Okay. Alright, so here it's saying determine the vertex and direction of opening for each quadratic function, then state the number of zeros. Okay, so this is actually not too difficult a thing to do, right? Let's just go back to where we were here. Okay, so determine the vertex direction of opening. So a, for this first question, a is 4, k is negative 6. A times k is a negative number, right? Opens up, vertex below. A times k is a negative number, and we have, therefore, 2 zeros. Again, let's quickly demonstrate this. 4x squared minus 6. Draw it here. Set a to 4, d to 0, c to negative 6. I think actually it'll cap at negative 5, but you get the idea. If it was negative 6, it would just be down 1 further. It would still have 2 x-intercepts. Second question. Okay. Oh, sorry. The second question over here, we have a equals negative 2. It opens down. We have k equals 0. It is on the x-axis. And therefore, we have a times k equals 0. And therefore, we have 1 0. Okay, so there's 1 0 only. Again, if you draw this one, negative 2x minus 3 squared. You get that. Okay, so you can see it has 1, 0, and that 0 is on the x-axis there itself. Okay. Now, to go back to where we were. It says factor each quadratic equation to determine the number of zeros. Now, in this case, you can't tell me the number of zeros in this form right off the bat because these are not in vertex form. You don't know where the vertex is, right? You need to know where the vertex is in order to use the idea we were using above. So what we're going to do here is we're going to factor. If it's factorable and the factors are different, you have 2 zeros. If it's factorable and the factors are the same, there's 1 0. This, by the way, is another case of a perfect square trinomial. If it's not factorable, you do not know how many zeros there might be. It's possible you can't factor it and there are still 2 zeros, you just can't find the factors. So it proves that there are 2 roots, or it proves that there is 1 root. It does not prove that there are no roots if you cannot factor it. Let's try to factor the first one. 4x squared minus 24x minus 36. Factor out of 4, we get x squared minus 6x minus 9, which we then factor into 4x minus 3 squared. No. Sorry, I fell into a trap. It's not minus 3 squared. We're looking for 2 numbers that add up to negative 6 and multiply to negative 9. Those 2 numbers don't exist. So what I'm going to do here is I'm going to say this is not factorable. However, it being not factorable does not tell you how many zeros it has. So you can't. You'd need another technique. Let's go back to the question and edit it for a sec. Let's imagine the question said plus 36, so that instead of minus 9, we had 4x squared minus 24x plus 36. Therefore, we had 4x squared minus 6x plus 9. Okay, then we factored that, and we realized that 2 numbers that add up to negative 6 and multiply to positive 9 are negative 3 and negative 3. So it's 2 of the same numbers. So it's a perfect square trinomial. It has 1 0 located at 3 0. Okay, so that's the only 0 this one would have, and it's so it has 1. Let's just write here. Sorry, unknown number of zeros. Okay, if the question was written like this with plus 36, then we can see that there is 1 0. It's located at 3 0, and this is where the vertex is. Okay. Now the second question says 2x squared minus 5x minus 7. We'll try to factor this. We're looking for a sum of negative 5 and a product of negative 14. Those 2 numbers are negative 7 and positive 2. So we get 2x squared plus 2x minus 7x minus 7. If we decompose it, factor out 2x, we get x plus 1. Plus 1. Factor out negative 7, we get x plus 1. 2 brackets are the same. We get 2x minus 7 and x plus 1. We factored into 2 distinct brackets. Therefore, there are 2 zeros. Okay? So that's that one done. So let's recall. If you factor and find the same thing, there's 1 0. If you factor and find 2 different brackets, there are 2 zeros. If you cannot factor, you do not know the answer. It's an unknown number of zeros. So you don't write there's none, just say that's an unknown number or use a different technique. What we're going to do now is figure out how to use a different technique. Let's think about the quadratic formula for a second. The quadratic formula is the different technique, by the way, that I was just mentioning. If you can't factor something, then what your option here is to create the quadratic formula. Sorry, I keep looking up here because I think it's supposed to be here, but it's not. Oh, here we go. Sorry, one of these things is the quadratic equation. Just save me a little bit of time if I can find it, but there we go. Okay. All right. So this is the quadratic equation. Remember, it tells you the number, the roots of any quadratic. So you look at this one, you go, okay, 7x squared plus 3x plus 1. I can't factor it because nothing multiplies to 7 and adds up to 3. So I would have to use the quadratic formula. Now think about the quadratic formula. Let's go back to the quadratic formula the way we wrote it when we first learned it. It was negative 2b over 2a, remember, which is the equation for the vertex. So it's the vertex plus or minus a certain distance. Now, if the distance exists, so in other words, if b squared minus 4ac is a positive number that you can take the square root of, you are going to find two zeros. If b squared minus 4ac is equal to 0, right, you're only going to find one zero. If b squared minus 4ac is a negative number, then when you try to square root it, it doesn't exist, and there are going to be no zeros. So this is a very, very, very good test for you to tell how many different intercepts there are on a quadratic. Let's go back here and we'll just quickly we'll design a sheet that can kind of illustrate this for us. So we'll make an A, we'll make a B, we'll make a C, and then we're going to make a discriminant. So we'll call it D equals, and then okay, so the square root b squared minus 4ac. Oh, sorry, I think I have to use the other bracket. There we go. Okay, so the discriminant is going to be b squared minus 4ac, and d is, in our case, is going to be equal to, so let's go square root our actual number b squared minus our 4 times our number a. I'll put them in brackets, I guess, make this a bit easier to see, and then our number c. All right. And one last thing here, we'll make another one, d equals, okay, so b squared minus 4ac. And actually, sorry, I'm making a mistake here. You don't actually need the square root. You just need b squared minus 4ac, because we're already made the interpretation if it's positive or negative. Okay. So there we go. So here's a sample quadratic. So let's draw it. A times x squared plus b times x plus c. Now look at this thing. This quadratic, which is 1 squared, 1x squared plus 1x plus 1, right? Is what I currently have. And you can see it has no roots. And when I look at its discriminant, right, which is over here, b squared minus 4ac is a negative number, right? And that negative number is my hint that this has no roots. Now let's change some values. Let's make c a little lower. What if c is negative 1.5? Well, now my discriminant has a value of 7, and you can see my quadratic has two roots. If I change this so that the discriminant is exactly equal to 0, right? Which would be done by this equation, then you can see my quadratic now only has one root, right? When the discriminant is 0. So the discriminant is really helpful, right? We can make a, b, and c a bunch of different numbers. So let's make a that, c that, and b that, right? And you can see that like this quadratic has two roots because its discriminant is a positive number. Now, for our case, we were supposed to do 7, 3, and 1. So let's make a 7, b is 3, and c is 1. Now again, looking at this equation, you can see, like if you just graph the parabola, you can see that it opens up, its vertex is positive, it has no x-intercepts. Its discriminant is negative, and therefore it has no roots. Let's go and demonstrate this with the discriminant. So 3 squared minus 4 times 7 times 1. That's equal to 9, take away 28, which is equal to negative 17. Therefore, there are no roots. Okay, so you don't need to draw anything, you don't need to do any complex calculations, you just do this quickly and you can figure out the number of zeros. Now this one, right, we already know this one's going to have 2 roots because it opens up and its vertex is down, but let's just use the discriminant as an idea. B squared minus 4ac. Let's just write down what we know. A is 5, B is not there, right? B is 0, and C is negative 5. So we're gonna go ahead and actually calculate that. We get 0 squared minus 4 times 5 times negative 5, which is equal to 0 minus negative 100, which is equal to positive 100. Therefore, 2 roots. Okay, if we draw this one, 5x squared minus 5, let's just quickly draw it. So A is 5, C is negative 5, B is 0. So this is 5x squared minus 5, and you can see it has 2 roots exactly as we predicted. Its discriminant is positive, and it has 2 roots. Your discriminant is a really useful shortcut if you want to know how many solutions a question has. Here it says, for the profit function so-and-so, determine whether the company can break even. Okay, so remember, break even is P of x equals 0. It means that the company can achieve 0 profit. So 4.2 x squared plus 18.12x minus 10.8, right? And what we want to do here is we want to note A is equal to negative 4.2, B is equal to 18.12, C is equal to negative 10.8, and then we use our discriminant. 18.12 squared minus 4 times negative 4.2 times negative 10.8. Okay, 18.12 squared, let's just quickly get GeoGebra to do that for us. So 18.12 squared is 328.33. And then we have 4 times 4.2 times 10.8 is 181.44. And you can see that this number is a bigger number, subtract a smaller number, which is definitely greater than 0, therefore 2 zeros. So the company can break even in 2 different ways. Remember, if you think back to the theory behind this, it can sell just enough or it can charge just enough, right? The 2 different ways that this could happen. Then it says if the company can break even, okay, we prove that it can. Determine how many ways it can do so. So again, there are 2 ways it can do so. All right, so again, let's just graph this one quickly so we can demonstrate it visually again. So profit function is equal to negative 4.2x squared plus 18.12x plus 10 minus 10.8, was it? Negative 4.2, 18.12, 10.8. Yeah? Okay, so there's the equation. And you can see that, yes, there are 2 ways that it can break even. It can break even over here or over here. Notice we didn't actually have to find out the x, right? It just said how many ways can it happen. We knew it could happen 2 different ways, right? But we didn't know where they are. If we needed to know where they are, we'd need to do the full quadratic formula and actually get the answer. Okay, here's a really good question for your communication. This is communication thinking. I always ask questions like this. It says, for what values of k will the function have 1 x-intercept? Okay, so 1 x-intercept, right? You should know that 1 x-intercept means the discriminant is equal to 0. Therefore, b squared minus 4ac equals 0. A in our question is 5, B is negative 6, C is just k. We don't know what it is, right? So we're going to write the discriminant, negative 6 squared minus 4 times 5 times k, but I know that this equation must be equal to 0. So I can say 36 subtract 20k equals 0, and therefore 36 equals 20k. And therefore, k is equal to 18 over 10, 9 over 5. Okay, so that would say if k is equal to 9 over 5, this question, for what values of k will this function have exactly 1 intercept? If k is 9 over 5. Let's demonstrate this. So let's make the equation again. So I've got 5x squared minus 6x plus k. Okay, and we make a slider for k. Now you can see if k is 1, I have 2 x-intercepts, right? And if I make k more negative, it doesn't help me. So I need to make k a little bit bigger than 1. So let's try and get down and isolate a specific value. Okay, let's zoom in really close here. So it's like if k is exactly this number, right, 1.25, we get an answer, right, where it has exactly 1 x-intercept. I seem to have done this wrong. Let's just find the mistake here. Oh, sorry, I put, it should be, if we divide them both by 4, we get 9 over 5. Oh, I see. I wrote the wrong thing in this. Sorry, I'm thinking to myself, what have I done here? Sorry, this is the wrong equation. Okay, so let's go back for a sec. So 5x squared minus 6x plus k. All right. So if k is down here anywhere, it's too small. If I make k the perfect number, it happens right here at 1.8. And if we just round this a little bit better, if k is 9 over 5, which is 1.75, then we know we are, sorry, 9 over 5. Oh, sorry, 1.8 is actually the answer, not, sorry, I'm doing the math wrong here. Lots of mistakes today. Okay, k is 9 over 5. If k is 9 over 5, you can see the graph has exactly 1 x-intercept, and we were able to do that by using the discriminant. Okay, so 1 x-intercept means the discriminant must be 0. We took the discriminant, we made it 0, and we figured out a k that would make that all work out. Now the last thing for today is it says, for what values of k will the function 8x squared plus 8x plus k have no zeros? Okay, so let's try the same thing I did here, but hopefully do a better job. So here's x squared plus 8x plus k. And you can see that if I want no zeros, then I want k to be a bigger number than this. I want k to be above this value. So k, like, it has to be like 16. Looks like it's about 16, right? So there it is with 16. With 16, there's exactly 1. If it's any lower than 16, there's going to be 2. If it's higher than 16, there aren't going to be any zeros. So what's the trick to figuring out a question like this? To solve this question, what you're going to do is you're going to set up the discriminant. Set the discriminant less than 0. If there are no zeros, there are no x-intercepts, that means the discriminant is negative. So we go b squared minus 4ac is less than 0. It's a negative number. So let's write in what we know. A is 1, b is 8, c is k. We don't know c, right? So let's fill in what we know. 8 squared minus 4 times 1 times k has to be a negative number, right? So let's go 16 minus 4k is less than 0. Let's move the 4k to the other side. And therefore we get, sorry, not 16. 8 squared is not 16. 8 squared is 64. Okay, then we get 16 is less than k. So there's our solution. K must be a number bigger than 16 in order to give this answer. Okay? Now I want to make a quick note here about an inequality. I solved this equation, right? I moved things to the other side of this inequality, which you are allowed to do, okay? But the only thing to just be careful of is you cannot divide both sides by a negative number. Watch what would happen if I did the question again. So let's do the question again, but this time let's solve it a bit differently. So let's go 8 squared minus 4k is less than 0. negative 4k is less than negative 64, right? You bring that negative 8 squared to the other side. And then if I divide both sides by negative 4, I get k is less than 16. But this is wrong, right? K is not supposed to be less than 16. K is supposed to be bigger than 16, right? So we messed something up here. So what we messed up here, and just to clarify how this works, is there's a mistake right here. So, and the mistake is, if you divide both sides by a negative, you must flip the inequality. Okay? This is the only special rule with inequalities. It's fine to add to both sides. It's fine to multiply, to subtract to both sides. If you multiply both sides or divide both sides by a negative number, the inequality has to flip. So it's not that k is less than 16, it's that k is greater than 16 because I multiplied or divided by a negative number. And that is the correct answer. If you're not sure, if you find that confusing or you don't want to get into this inequality stuff, it's okay. What you should do then is solve the question as though there was 1 0. So let's go back for a sec. 8 squared minus 4k equals 0. Then we get 8 squared equals 4k, and then we get 64 equals 4k, and k equals 16. So what this tells you is there is 1 0 when k equals 16. So now you just have to check the other two options and test. Test if there are 2 zeros when k equals 15, for example. So what if k is a little bit less than 16? Are there 2 zeros? Let's check, right? 8 squared, right, minus 4 times k, which is 15, would be 64 minus 60, which would be 4, which is bigger than 0. So there are 2 zeros if k is less than 16. Test if k is greater than 16. Let's say if k equals 17, for example. Get 8 squared minus 4 times 17, which is equal to 64 minus 68, which is equal to negative 4, which is less than 0, and there are therefore no zeros in the answer. Therefore, k greater than 16 will produce no zeros. Okay, so there's a couple of ways you can do this. You can do it the inequality way if what I did there makes sense. If it doesn't make sense, then what I would suggest is set it equal to 0 and get the answer. And then you can just check, is it the greater than answer that I want to keep, or is it the less than answer that I want to keep? Okay, and that basically sums up just the ideas. This table here sums up the ideas from today. We'll continue on with another lesson in the future.